Good day everyone, welcome to our class in Construction Materials and Testing CE313. So for today, we are going to discuss our Unit 3 and it will be all about aggregates. So what do we mean by aggregates? Construction aggregate, or simply aggregate, is a broad category of coarse particulate material used in construction, including sand, gravel, crushed stone, slag, recycled concrete, and geosynthetic aggregates. So yung sand, alam nyo naman na siguro na buhangin yon. Gravel naman is yung bato. Yung crushed stone naman natin, so these are aggregates that comes from a large rock or boulders, then processed in a crushing plant or mobile crusher to attain its required size. So pag sinabi naman natin na slag, so that is a synthetic aggregate. Pagka sinabi naman natin na recycled concrete, so those are crushed concrete aggregates, also called as recycled concrete aggregates. So those are from fragments and pieces of concrete building which are demolished or rebuilt. These crushed concrete are cleaned from dirt and broken to smaller pieces to manufacture aggregate, which is termed as recycled aggregate. These are commonly used as base of drainage structures and in road construction. Pag sinabi naman natin na geosynthetic aggregates, so these are products used to stabilize a terrain. So they are generally polymeric products. When we say polymeric, so ang example niyan are nylon, polyethylene, polyester, Teflon, and epoxy. Those are man-made products. Aggregates are divided into two sizes. We have fine and coarse. When added to cement and water, it produces concrete. Sand is considered as fine aggregate and stone or gravel as a coarse aggregate. Aggregates are the most widely used products resulting from extracting and processing non-metallic construction materials. Now, where do we commonly use the aggregates? In general, aggregates can be used in a number of ways in construction. In roads, aggregates are components of sub-base course and base course. In railway, so it is used as railway ballast. So here, aggregates are used to resist overall static as well as dynamic load. Aggregates as ballast can distribute the load properly to the supporting ground and to drain off water from the surface. In concrete, aggregates are used for economy, reduce shrinkage, cracks, and strengthens the structures. Aggregates are also used in water filtration and sewage treatment processes. As summarized, these three are the general uses of aggregates. So that is as load-bearing material in roads and railways, filling materials in concrete, and infiltrating materials in water filtration and sewage treatment plant. Aggregates is an essential ingredient of concrete. A mixture of fine aggregates and coarse aggregates must be used in concrete. Like in the figure shown, we cannot completely fill the jar if we only use the coarse aggregates. The space left by the coarse aggregate can only be filled by the fine aggregate. For this reason, control of particle size distribution is important in the choice of aggregates. So, pagdating sa concrete, hindi po pwede na fine aggregate lang ang gagamitin natin. Kasi, the smaller the aggregate size, the greater its surface area, and the more binding materials or cement will be required, resulting in a higher cost of concrete. Kung coarse aggregate lang naman din ang gagamitin natin, walang kasali na fine aggregate, so ano yung mangyayari? So the greater the aggregate size, the larger will be the voids, resulting in a wastage of binding material, which is the cement. So we must use a mixture of coarse and fine aggregate when using it for concrete. Kanina, nabanggit natin yung particle size distribution. So, saan ba natin makikita o malalaman yung tamang particle size distribution? So, here in the Philippines, we have the DPWH Blue Book. When we use aggregates as part of concrete, for example, in PCCP, so yung PCCP, ibig sabihin nun ay Portland Cement Concrete Pavement, which is the roads. This is also known as item 311. So these are the specifications. So it shall consist of natural sand, stone screening, or other inert materials with similar characteristics or combinations thereof, having hard, strong, and durable particles. Fine aggregates from different sources of supply shall not be mixed or stored in the same pile, nor used alternately in the same class of concrete without the approval of the engineer. So the fine aggregates shall be well graded from coarse to fine and shall conform to Table 311.1, which is the grading requirements for fine aggregates. So, dito makikita natin meron tayong Sieve designation and the mass percent passing. So, before we discuss this table, alamin muna natin yung aparatos na ginagamit, especially this Sieve. So, in particle size distribution or Sieve analysis test, we use a stack of sieves. Sieves are actually strainers with various sizes to characterize and classify aggregates. In our CE laboratory, these are the sieves that we have. Presented in the table are the sieve number and opening sizes or yung size ng mga butas. So we have sieve number 4, 8, 16, 30, 40, 50, 100, 200, and pan. Habang lumalaki yung sieve number, lumiliit naman yung butas niya. Yung pan natin, sarado na yon. And may cover din tayo sa taas. So basically, yung sample natin, ilalagay lang natin sa sieve number 4, then tatakpan, ilalagay sa sieve shaker, then ano mangyayari? So magkakaroon ng mga aggregates na mareretain per sieve. Yun ngayon ay titimbangin, then divided by the total weight of the sample. So from there, we could determine the percent passing. Ngayon, balik tayo dun sa specification natin sa fine aggregates. So sabi dito, 100% passing dapat ng sample ang nag-pass sa sieve number 3/8. So paano kung may na-retain? So it only means that the fine aggregates does not conform with the specifications. So as a material engineer, pwedeng reject yung fine aggregates or may mali dun sa naging sampling. So ngayon naman, for coarse aggregate, ito naman siya. So it shall consist of crushed stone, gravel, blast furnace, slag, or other approved inert materials of similar characteristics or combinations thereof, having hard, strong, durable pieces and free from adherent coatings. Only the grading specifications shall be used from any one source. So, we have table 311.2. So, these are the grading requirements for coarse aggregates. So, dito sa may grading requirement for coarse aggregates, meron tayong grading A, grading B, and grading C. So, kailangan mag-conform yung ating sample sa kahit isa dito sa mga grading na ito. Now class, let me just remind you that these grading requirements are only applicable for PCCP. If the aggregates will be used for other functions like structural concrete, base course, sub-base course, so iba ang grading requirement doon. So to sum it up, the goal of aggregate proportioning and sizing is to maximize the volume of aggregate in the concrete while preserving the strength, workability, and finishing. This balance the proportion of each. So there are just enough of each size to fill all the voids while preserving workability and cast surface quality. Now, let's get to know more about fine aggregates. So, in general, these are materials that pass Sieve number 4 and will, for the most part, be retained on Sieve number 200. So, again, its purpose is to fill the voids in the coarse aggregate and to act as workability agent. So yung mga fine aggregates daw, dapat 100% mag-pass siya sa Sieve number 4 and possibly yung karamihan is ma-retain sa Sieve number 8, 16, 30, 40, 50, 100 until 200. So next naman is para sa coarse aggregates. So coarse aggregates are the materials that pass the 3-inch screen and will retain in Sieve number 4. So, ang partition ng aggregates for it to be identified as fine or coarse is the Sieve number 4. So, lahat na mariretain mula sa Sieve number 4, pataas, so that is coarse aggregate. Kapag ka naman yung nag-pass sa Sieve number 4, pababa, papunta sa pan, that is fine aggregate. Kaya yung Sieve number 4 is the dividing line between the coarse aggregate and fine aggregate. Now, for additional information as future engineers, civil engineers, so sa construction site, fine aggregates or sand is also known as S1. Sa coarse aggregates naman, meron tayong 3/4, 3/8, at G1. So, yung 3/4 that is typically used for driveways, walkways, and buildings. So, next naman is yung 3/8. So, this is also known as P aggregates. So, these are typically used for asphalting and paving blocks. And next, we have G1. So, G1, it only means gravel 1. Yung 1 is 1 inch. So, meron din tayo class sa site na G2, G3, and then next na doon is yung tinatawag na natin na boulders. Now, let's discuss our Unit 3, which is all about the laboratory test in aggregates. To start with, let's have our overview. So, this unit will discuss the proper procedure on how to conduct particle size distribution test or Sieve analysis test, specific gravity and water absorption of coarse aggregate, and aggregate crushing test using Los Angeles abrasion machine with accordance to ASTM D6913, ASTM C127, and ASTM C535. So each test includes their testing objectives, scope, apparatus required to use, safety and precautions for materials, apparatus, and equipment to be used, step-by-step on how to conduct test procedure, tabulation of data, calculation, and test result. Activity on each test are incorporated in the last part of each test to ensure student will develop their practical skills. So, yun yung laboratory natin. Now, let's have the learning objectives. So, first is to understand the use of Sieve set in Sieve analysis, plus basket in specific gravity, laboratory hot air oven in water absorption, and Los Angeles abrasion machine in aggregate crushing test. So, next is to discuss the proper step and procedure of Sieve analysis, specific gravity, water absorption, and aggregate crushing test of coarse aggregate. Next, we also have to determine and calculate the percent pinor of particle, specific gravity, water absorption, and aggregate crushing value of coarse aggregate. Next is graph particle size distribution result. And then next is to determine the type of aggregate used in terms of water absorptions and limits, and then develop their practical skills by performing each test. So, dito sa aggregates natin, meron tayong tatlong test na matututunan. So, una na dyan is the particle size distribution test or the Sieve analysis test. Next is the specific gravity and water absorption of coarse aggregate and aggregate crushing test using Los Angeles abrasion machine. So let's have first the discussion of particle size distribution or Sieve analysis test. So this test procedure is in accordance to ASTM C136. So for our particle size distribution or Sieve analysis test, here's our testing objective. So the particle size distribution or Sieve analysis test determines the different proportion of grain size as they are distributed among certain size ranges. So ano yung scope ng test na ito? So a 75 mm square opening sieve size to 0.0075 mm will be used to separate each particle size based on its size range. So it will also determine the mass retained on each size. So what are the apparatus required in this laboratory test? So first is the stock of sieves including pan and cover. Next is a digital weighing scale. Next is a rubber mallet and mortar. Next is the mechanical sieve shaker. So, ito na-discuss naman na natin kanina. So, the stock of sieves including pan and cover. In our laboratory, these are the sieves available. And then, mapapansin nyo nga, habang pataas yung number ng ating sieve, paliit naman ng paliit yung kanyang butas. So, here's our safety and precaution. So, first is to clean the sieve set so that no soil particles were stuck in them. So, mahalaga yon kasi titimbangin din natin isa-isa mamaya yung mga sieves natin. So, mahalaga na walang mahalo doon na iba kasi makaka-apekto yun doon sa result ng ating test. So, next is while weighing, put each sieve with soil sample on the balance in center position. Next is to always check the sieve shaker electric connection before conducting the test. Now let's have the test procedure. So the following procedure was adopted in ensuring that the data to be recorded from sieve analysis test specimen was taken in an organized and consistent manner. So first is to prepare at least 500 grams of dried sample of soil. So remember from our last unit, for every 1,500 cubic of fine aggregates, 50 kilos must be obtained. Kapag ka naman coarse aggregate, so 70 kilos must be obtained. So, ang dami nun, 'di ba? Bakit ang dami? Tapos, sa test natin, 500 grams lang pala yung gagamitin. So, yun ay dahil isang test pa lang naman ito. So, meron pang ibang test na ginagawa para sa ating mga aggregates. So, dapat dried yung sample natin kasi pag basa, makaka-apekto yun dun sa result ng ating test. So, next is, if soil particles are lump or undisturbed, use mortar and mallet to specimen until it reaches its natural shape. So, if ever may buo-buo sa sample natin, so nangyayari naman yun, lalo na kung moist yung ating sample, so pwede kang gumamit ng mortar or rubber mallet. So, next naman is to ensure that no manipulation exists in this test. So, use quartering method for equal distribution of soil particles. So, ano ba yung quartering method? So, quartering is an alternative method of reducing the size of bulk aggregate sample where a sample divider o yung tinatawag natin na rifle box is not available. So, dun sa sample natin na 50 kilos or 70 kilos, hindi pwedeng kukuha ka na lang ng 500 grams. Ang kailangan mong gawin ay quartering. If hindi available ang rifle box. So, paano ba ginagawa ang quartering? So, ganito yon. The bulk sample should be shoveled to form a cone and turned over to form a new cone. This being done 3 times. The third cone should be flattened to an even layer of 75 to 100 mm thick and then divided into 4 equal quadrants with 2 diagonally opposite quarters being discarded. The procedure is then repeated on the remainder until the desired size of sample remains. So next, ano naman yung rifle box? Sabi nga natin kanina, pwede lang natin gawin yung quartering kung wala tayong rifle box. Ngayon, alamin natin, ano ba yung rifle box? So, ito kasing rifle box, wala tayo nito sa ating CE laboratory. Kaya may video na lang ako na ni-ready na galing sa YouTube. So, panoorin lang natin sandali.
AASHTO T248, reducing samples of aggregate to testing size, covers the reduction of large samples of both coarse and fine aggregate to the appropriate testing size while maintaining the representative nature of the samples. First, let's examine the procedure for reducing a sample of fine aggregate. For an aggregate to be categorized as fine, 100% of the material must pass a 3/8 inch sieve. For samples that are saturated surface dry or drier, use method A, the mechanical splitter. If your sample is wetter than saturated surface dry, use method B, quartering, or method C, miniature stockpile. If the moisture condition of your sample is not apparent, determine its condition by performing the fragile hand cast. Just squeeze a handful of material. If it retains its shape, assume that it is wetter than saturated surface dry. If you desire to use method A, you must first dry wet samples to the SSD condition or drier. But when doing so, be sure that your temperatures do not exceed those specified in the test you will perform on the sample. Method A employs the use of a mechanical splitter having an even number of chutes, not less than 12. Which discharge alternately to each side of the splitter. The chutes may be no wider than 3/4 of an inch, but must be at least 50% larger than the largest particles in the sample. The hopper shall have a width that is equal to or slightly less than the overall width of the chute assembly. The receptacles must catch the entire discharge from the chutes. Now, let's look at the procedure. Introduce the sample such as to allow free flowing through the chutes into the receptacles below. Approximately equal amounts should flow through each chute. Obtaining a tare weight of your receptacles provides an easy way to check approximate sample masses during the reduction process. Reintroduce the material from one receptacle as many times as necessary to attain the specified mass for the intended test. Record the mass of the test sample and any other pertinent information. The remaining material may be saved and further reduced for other tests. Method B employs the use of a hard, clean, level surface or a canvas blanket. It's always a good idea to brush the surface before you begin. Place the sample on a hard, clean, level surface that will not contaminate the sample. Brush or wipe clean all utensils that will be used during the procedure. To ensure the material is thoroughly mixed, the entire sample must be turned over a minimum of 3 times. With the final turning, create a conical pile. Flatten the pile to uniform thickness and diameter. Be careful to push straight down and not slide the material around. The intent is to maintain the material composition of each quarter as if separators had been inserted into the conical pile. The diameter of the resulting pile should be from 4 to 8 times its thickness. Divide the pile into 4 equal parts using a straight edge tool. Remove diagonally opposite quarters, making sure to remove all fines. Continue mixing and quartering in this manner until you have a sample of the desired size. Used for damp fine aggregates only, Method C is procedurally identical to Method B, except that the conical pile is not required to be flattened, and a small sample thief or a small scoop or spoon is used to obtain the desired sample. From the resulting miniature stockpile, obtain a sample for each test by taking a minimum of 5 increments from randomly selected locations. Now, we'll reduce a sample of coarse aggregate. Coarse aggregate samples may be reduced using Method A, mechanical splitter, or Method B, quartering. Method C is not suitable for aggregates containing coarse particles. The riffle splitter, used in reducing samples of coarse aggregate, must have an equal number of chutes, but no fewer than 8. Each chute must be approximately 50% larger than the largest particle in the sample. We're using a splitter that's set up for aggregates with a maximum particle size up to approximately 1 3/8 inches. The configuration is basically the same as the fine aggregate splitter: a hopper above the chute assembly and 2 catch pans. The procedure is exactly the same as with fine aggregate. Uniformly distribute the sample in the hopper and regulate the rate to allow a free flow of material through the chutes to the catch pans below. Reintroduce the material from one receptacle as many times as necessary to attain the specified mass for the intended test. When using Method B, the procedure is the same for either coarse or fine aggregate. It will be more difficult to flatten a conical pile of aggregate containing coarse particles. Extra care must be taken to maintain the material composition of each quarter as much as possible. Remember, the purpose of this standard is to reduce a field sample to testing size while maintaining the representative nature of the sample. Method A is preferred when applicable. It is important to collect all fines and to avoid any loss or contamination of material. For more details on the most recent specifications, consult the latest AASHTO publication, which may be ordered by calling 202-624-5800 or online at transportation.org.
Now, whether we choose quartering or we have rifle box, once the right quantity of sample for this test is determined, we can now continue. So, using the digital weighing scale, we must determine accurately the mass of sample and label it as the total weight. Yung sample ngayon na sinasabi natin dito, so ito na yung galing dun sa quartering or sa rifle box. So next is to prepare stock of sheaves correctly. Make sure that the larger opening size will be placed on top of the smaller one. So ito yung tamang pagkakasunod-sunod nung ating mga sheave. So sheave number 4 sa taas, then sa ilalim naman yung ating pan. So next is that make sure that each sheave is clean. If you notice that soil particle is stuck in the opening, brush it until soil particle is removed in the opening. So next is to determine the initial weight of each sheave and pan. So titimbangin natin isa-isa yung ating mga sheave. So here in table 1.1, so meron tayong sa column number 3, so these are the mass of each sheave. So sabi nga dito, So, in table 1.1, considering these three columns, so are the example of data gathered from the Sieve analysis test. So, the given Sieve set in the table are based in the available laboratory equipment in CE laboratory. So, next is to put the weighted soil from step 3 into the stock of Sieve from the top and place the cover. Next is to place the stock of Sieve in the Sieve shaker and lock the two-side clamp to make sure that the stock of Sieve will not move before operating. And operate the Sieve shaker for at least 5 to 10 minutes. So next, when Sieve shaker stops shaking, determine the mass of each Sieve with retained soil using digital weighing scale and record it in table 1.1 in column 4. So, ang next natin gagawin after natin siyang ma-shake ay timbangin yung ating mga Sieve kasama yung mga soil na na-retain. So, ito yung mga nakuha natin. So, for Sieve number 4, we have 765.80. Then, sa dulo, Sieve number 200 tayo. 896.30 na yung kanyang timbang. So, ito na yung table natin. Ito na rin yung column 4. So, ano ba ang kailangan natin ma-determine pa? So, we need the mass of soil retained for column 5 para ma-identify natin yon. So, paano ba yon? Simple lang naman. So, we must take the difference of column 4, the weight of the Sieve plus the soil retained, minus column 3, which is the weight of Sieve. So, makukuha na natin yung weight of soil retained. So, i-minus lang natin yung mass of Sieve dito sa mass of Sieve plus retained soil. So, that is 765.80 less 734. 789.40 minus 734. So, ito yun. So, next naman is to determine the percentage on each Sieve. So, that is simply the weight of soil retained divided by the total weight of aggregates multiplied by 100. So, we have 3.18%. So, that is simply 31.8 divided by 1004.2. And then, this 55.40 divided by 1004.2, 78.80 divided by 1004.2. So, that will give us, para dito, 3.18, 5.54, 7.88. Okay? So, next. We are asked to determine the cumulative percent retained until Sieve number 200. So, pagdating dapat ng Sieve number 200, 100% na siya. So, that is simply 3.18 plus 5.54. So, that will give us, so, dito sa una, 3.18. So, next is 3.18 plus 5.54. So, that is 8.72. 8.72 plus 7.88, that is 16.6. 16.6 plus 17.66, that is 34.26. 34.26 plus 24.20, so that is 58.46, and so on. So, last. So, we are asked to determine or calculate the percent piner using the obtained data. So, ito yun. So, with the cumulative percent retained with its corresponding Sieve number, the value of percent piner will be determined using the given calculation formula. So, that is the percent piner is equal to 100 minus yung ating column number 7. Now, here is our final Sieve analysis. So, dito makikita natin that in Sieve number 4, that is 96.82% piner. And then for Sieve number 8, that is 91.28% piner, and so on. So, next is that to complete this, we must plot the points in figure 1.0 of each Sieve size between particle size and percent piner. So, kailangan lang natin siya na i-plot. So, here, in figure 1.0, so that is the data that we obtain, so naiplot na siya. So each plot represents its equivalence sieve opening in size and percentage until coming up to a continuous curve. So with the help of this figure, it is easy to identify the amount that retains or pass through each sieve opening size that is being used. So here is the summary of computation used in this laboratory. So we have the calculation of the mass of soil retained for each sieve number, percentage on sieve number, then yung cumulative percent of soil retained, and finally yung ating percent passing. So that's it for particle size distribution or sieve analysis test. So next meeting, we will be discussing the other two tests in aggregates, which is the specific gravity and absorption of coarse aggregates, and then the Los Angeles abrasion test. So thank you, class, for listening. God bless you and stay safe.